Hi everyone, welcome to VMS class. In this video, I am going to explain how to train and evaluate gradient boosting algorithm for finding the customer churn prediction. So this project is mostly same as our previous project in that I have utilized the random forest classifier. Then in this, I am going to use the gradient boosting algorithm. The remaining cells are almost same. So first, you are going to import the CSV file into the Google Collaboratory. So once you got this file into this, you can execute this project cell by cell. Now, coming to the project, we are going to build a customer churn prediction system using gradient classifier. What is the meaning of customer churn here? Customer churn means a customer leaving a company or canceling a service. The model learns from the customer information such as tenure, contract type, internet service, payment method, monthly charges, etc. And the data set which I have collected is available in the Coggle. So this is the data set, telco customer churn data set. So this is mainly used for predicting the behavior to retain the customers. We can analyze all relevant customer data and develop focused customer retention programs. So you can download this dataset and upload it to the Google Drive as mentioned before. Okay. So in this, we have several columns. So in these columns, one of the column is considered as target. The target column is churn. That means no indicates that customer is staying. S indicates that customer is going to left. Okay. We are going to use gradient boosting, which is a boosting algorithm that builds multiple decision trees sequentially, where each new tree tries to correct the mistakes made by the previous trees. Coming to the first cell, we are going to import all the required libraries. So the one of the popular library for data analysis is Pandas to load and handle customer churn datasets. We use Matplotlib and Seaborn, which is mainly helpful for data visualization. Then train underscore test underscore split. It is used for dividing the dataset into training and testing data. Gradient boosting classifier to build the customer churn prediction model. Then we are going to import three evaluation metrics: accuracy score, confusion matrix, and classification report. And in this, the main thing is gradient boosting is an ensemble learning algorithm. As mentioned, it is going to build multiple trees sequentially, and each new tree tries to correct the mistakes made by the previous trees. Okay, now I am going to load the data set using td.read underscore csv. So this is our file which is downloaded from the Coggle, and I am displaying the top 5 records from that. Now you can analyze what are the columns that are available in this data set. Some of the columns mentioned: customer ID, gender, senior citizen, partner, dependents, tenure, phone service, multiple lines, internet service. You can see that there are so many columns are there. All these columns except the churn can be considered as input features. Now our target feature is a churn here, which is labeled with yes or no. Okay. Now I want to see how many records on how many columns are present in this. For that, you can use the df.shape. So that you can see totally there are 7,043 records are there, 21 columns are there. So here columns represents the customer details such as tenure, contract type, internet service, etc. And I want the additional information of this data set. How can you get that? You can use a df.info method. So this shows all the column names, okay, along with how many non-null values are there. So what is the D type of each and every column, how much memory it is occupying, all those details you are going to get. And this df.info can be useful to check how many numerical columns are there, how many categorical columns are there. So all these details you can get by using df.info. And you can see one of the column, that is total charges. So this may be stored as a text, okay, instead of numerical data. So we'll try to convert this total charges to numerical column in the upcoming cells. Okay, now first of all, try to understand here a very important thing. You need to identify any missing values are there. How can you get that? By using df.isNull.sum. You can notice that here there are all, okay, all columns are considered as zero. So it indicates that the data set is clean. Okay, but only one of the column, the total charges, okay, is specifically we need to handle, because this data set is considered as a, okay, text column. Here we need to convert that to the numerical column. Now how can you convert that? You can try to convert this using two numeric. Okay, this is my column df of total charges pd dot to numeric. We are going to convert this total charges column to the numeric. And what is meaning of error equal to queries here? So it is basically when we use this attribute, okay, errors equal to queries, so that invalid or blank values are converted into missing values. So then we are going to fill that missing values using the median here. Okay, so if any missing value is arised in this step, so those missing values will be filled with the help of median in this cell. Now the data is okay, converted to the numerical column, and if any missing value is there, that missing value is replaced with the median. Now try to check the df.info again. You can notice that this total charges column, previously it is a character or string type, but now it is converted to number style. Okay, now let us see some of the visualization things. Okay, some of the information about the data set again. In this cell, we count the values in the target column. What is the target column? df.churn, right? So here we are going to see how many no, okay, values are there. 5174. How many s values are there? We have 1869. Okay, so this helps us to understand how many customers stayed and how many customers churn. This is important because churn data sets are often imbalanced. Even we have there is a problem of imbalance here, but in this project I am not going to show you how to balance this data set. So my intention is to show how we can train this gradient boosting algorithm and evaluate the trained models. Okay, now let us visualize the churn distribution. So here we visualize this churn distribution using a bar chart. The x-axis represents the churn status. The y-axis represents the number of customers here. So this gives you a clear visual understanding of how many customers stayed and how many customers left. This is a kind of bar graph for the previous data frame which we have generated. Now in this cell, we are going to analyze the churn based on the contract type. So contract type can be a month to month, 1 year, 2 year, etc. Right? Customers with a month to month contracts usually have higher chances of leaving because they are not locked into a long term plan. So this chart is going to helpful to understand how contract type affects the churn behavior. Now we can see the visualization of monthly charges versus churn. So for this I am going to draw a box plot. So we can compare the monthly charges between customers who stayed and the customers who left. So we use a box plot for this, right? So basically the box plot helps us to understand whether the customers with a higher monthly charges are more likely to churn. In many telecom business, higher monthly bills can be one of the reasons for customer churn, right? So now this is some of the basic visualization we have. Now let us continue how we can train the models. Okay, first of all, we need to separate the entire data frame into the input features and output features. So we remove the customer ID and churn columns from the data frame and making the other attributes as input features, right? Because the customer ID cannot help in any model training process because it's just basically an ID. And now I am going to take the churn column into the Y category because it is the target column. Okay. Now we need to encode the target column. Here we have the labels yes and no. We are going to encode the target column churn because this is contains the text. So no means the customer stayed, yes means the customer will leave, right? Machine learning models work better with numerical labels. So what I will do, I am going to convert this no to 0, yes to 1. Okay, now the target column contains zeros and ones. The next cell is about encode the categorical columns. Now, many columns in this data set contains the text values. For example, you can take gender, okay, partner, internet service. All these are like categorical columns. So machine learning models cannot directly understand these text values. So what we have to do here, you need to encode that text columns to the numeric by using pd.getDummies method. Then I am going to store the result into x underscore encoded. I am going to display all the columns here. Now you can see that there are totally 30 columns are there. Okay. Now with this encoded data, okay, x underscore encoded, we are going to split the entire data frame into train and test parts. Now you can see the train underscore test underscore split, which can be useful for separating the data into training and testing data. Training data is used to train the gradient boosting model. Test data is used to evaluate how well the model performs on unseen examples. So we use totally 80% of training data for training and 20% data for testing. In the next cell, this is the main logic which is going to helpful for creating the gradient boosting classifier object and training. Okay, so we use a gradient boosting classifier here. So which is going to build the trees sequentially. So I have created a model here, model equal to gradient boosting classifier, n underscore estimator equal to 100. So there are 100 trees I am going to consider. So now in this step, I am going to train the model. Model dot fit x underscore train, y underscore train. Now the gradient boosting model is trained here. We need to evaluate on the test data. We have x underscore test model dot predict of x underscore text. So here the result we are going to store in the y underscore pred. And I am displaying y underscore pred here. You can see the output is containing zeros and ones. Here, which indicates that the output can be either 0 or 1. The customer can stay or he can leave that, right? Now, out of that, how many predicted okay values are actually okay equal compared comparison we are going to take here comparison equal to pd dot data frame of what are the actual values and what are the predicted values by the model. So can you display the top five? So you can see that some of the five samples I am taking actual value is 1, the model is predicted value also 1. Now, you can evaluate this model by using three different evaluation metrics which we have imported. So, one is the accuracy score. For the accuracy score, you can pass Y test and Y pred, store the result in the accuracy and display the result. You can see that the accuracy is around 80% accuracy. And I am displaying the confusion matrix which I am passing Y test and Y pred and display the confusion matrix. So you can notice that there are totally 170 plus 99, okay, mistakes are there. Even you can improve this model. The same confusion matrix, I am going to visualize it using the Seaborn package so that you can get this confusion matrix even in the more better format. Similarly, I am displaying the classification report, so which can be useful for identifying the precision, recall, F1 score and support values. In the next cell, I am going to show you what are the important features. So I want to consider the feature importance. So in which I am creating a data frame. One of the column is the feature. Okay, I am taking the x underscore encoded dot columns. And what is the importance? You can get the importance by using model dot feature underscore importance as underscore. So those importance, I am going to sort it and displaying in the form of a data frame. Now you can notice that each feature and importance score is represented in the data frame. So from this, you can identify some of the columns like tenure, internet service, fiber optic. All these features are going to affect the model. And the same data frame I am going to display in the form of a graph so that you can see that which feature is affecting the model. Okay. In the top place, you can see that we have tenure. Okay. Then we have the second internet service, fiber optic, payment, electronic check. So this is the same thing. The data frame I have displayed in the form of a graph. Now let us take the real-time customer input here. You need to pass all the values and I am creating a data frame and storing the data in the new customer data frame. Now you can see that this is the new data frame, so which contains all the values for the features. Now we need to do the similar kind of steps which we have used in the training. First, we need to encode the customer inputs. The encoding can be done with the help of get dummies method, the encoding. So for the new customer, the result we are going to store in the new customer encoded. Okay. Now what is happening here? I am going to take this new customer encoded dot reindex, so which is going to align the new customer input with the training columns. So missing encoded values will fill with 0 and then I am displaying the new customer encoded data. So this is my new customer encoded data. You can notice that this new encoded data is having 30 columns. Even our model was trained with 30 columns. So that is the reason we are going to convert our test data into the appropriate format for model prediction. Now directly you can pass this new customer encoded data for the prediction by using model.predict of new customer underscore encoded. The result is going to store in the prediction. So now if the prediction of 0 equal to 1, then we can say that customer is likely to leave, otherwise customer is likely to stay. So as per this data, we are going to predict that customer is likely to leave. Even you can get the probability as well by using model.predict underscore proba, so that you can print the probability, how much probability is there for staying, how much probability is for leaving. You can notice that there is a high probability of leaving this customer. It's around 64%. Okay, like this you can display the probability also. Coming to the final project insights, so we have learned few things. Gradient boosting is a boosting ensemble algorithm. It builds trees sequentially. Each tree learns from previous mistakes. The contract type and tenure strongly influence the churn. The model can predict the customer churn risk here. So this is the main idea behind the gradient boosting algorithm. So we handled even some kind of things like converting the categorical columns into the numerical columns and encoding. Then we have trained the gradient boosting model and we have evaluated on the test data and we have analyzed all the performance details. So try to practice this project cell by cell so that you can understand this in the better way. Thank you. I will see you in the next video.